Now let us represent x and y. Let x be the units manufactured by P, and similarly y units is manufactured by Q. So first point is 0, 10. Second point is, so it is 5, 1, 2, 3, 4, 5. This is B. 5, 0. Since it is a maximization, therefore the objective function is maximum z. Max z is equal to 10,500 x plus 9,000 y. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So today in this session I will take very important problems in linear programming problem, that is in LPP for 5 marks, formation of an LPP and the solution. So to form an LPP, formation of a linear programming problem formation as well as the solution. Form and solution using graphical method. Now, let us move on to the first problem. So, just go to the problem. What is the statement given here? A company. So, a company owned by Shri Group produces two products P and Q. So, the products are P and Q are the two products P and Q. Each P requires 4 hours of grinding and 2 hours of polishing. So, one is grinding, another one is polishing. So, P requires 4 hours of grinding and 2 hours of polishing, and each Q requires, this is for Q, whereas for Q requires 2 hours of grinding and 5 hours of polishing, right. So, the total available hours for grinding is 20 hours and for polishing it is 24 hours. Profit per unit of P is ₹6 and profit per unit of Q is 8. Formulate an LPP model and solve graphically. So here Shri Groups will produce us two types of products, that is P and Q. So each P requires 4 hours of grinding and 2 hours of polishing. So 4 hours for grinding and 2 hours for polishing for P. And similarly for the product Q, for Q, it requires 2 hours of grinding and 5 hours of polishing. Then the time available, the maximum time available for grinding is 20 hours. Similarly, the maximum time available for polishing is 24 hours. And the cost is given. Profit per unit of P is ₹6 and for Q it is 8. So we have to formulate the LPP and this should be solved using graphical method. Since the profit, this is nothing but the maximization. So the problem is maximization, max z, right. Okay. Now let us represent x and y. Let x be the units manufactured by P and similarly y units is manufactured by Q. Let x units be the manufactured by P and y units is manufactured by Q. Okay. Let us represent this in a table. So let us write the products first. Products, there are two products P and Q. Okay. These are the two products. Now grinding hours. And similarly polishing hours. And the last one is the profit per unit. So profit per unit. Then after this write the availability of time. So available time, so available time for grinding and for polishing, right. So what is the available time for polishing? The available time for grinding is 20 hours and polishing is 24 hours. So for grinding, available time for grinding is 20 hours, for polishing it is 24 hours, right. So the products are P and Q, right. So P requires 4 hours of grinding and 2 hours of polishing. So 4 hours of grinding and 2 hours of polishing. Similarly, Q requires 2 hours of grinding and 5 hours of polishing. So 2 hours of grinding and 5 hours of polishing. So the profit per unit for P it is ₹6 and for it is ₹8. That's it. Okay. Now using this formula, form an LPP model. Now therefore the required LPP is what is the objective function? It is max z is equal to max z is so 6x plus 8y. So x is nothing but the units manufactured by P and y is the units manufactured by Q. So 6x plus 8y. Subjected to constraints, what are the constraints? 4x plus 2y is less than or equal to 20. Okay. And similarly 2x plus 5y is less than or equal to 24, and the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. This is the required LPP model. This is the formation, first step. So just write down the products P and Q. So what is the given condition? The grinding hours are for P it is 4 hours, for Q it is 2 hours. Similarly, the polishing hours for P is 2 hours, for Q it is 5 hours, and the profit per unit of P is ₹6 and for Q it is 8. And the time available, the maximum time available for grinding is 20 hours and that for polishing is 24 hours. So based on this, if x and y are the units produced by P and Q, we can straight away write the objective function max z is equal to 6x plus 8y subjected to the constraints 4x plus 2y is less than or equal to 20 and 2x plus 5y. 4x plus 2y is less than or equal to 20. 2x plus 5y is less than or equal to 24, and the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. Now solve this. How to solve? Now let us convert this inequalities into equalities first. So we can write now therefore 4x plus 2y is equal to 20 is the first equation. Another equation 2x plus 5y is equal to 24. Now simple, put x is equal to 0. So then 2y is equal to 20, y is equal to 10. Therefore, the first point A is equal to 0, 10. Similarly, put y is equal to 0, 4x is equal to 20, x is equal to 20 by 4 is equal to 5. Therefore, the point B is equal to 5, 0 is the one point and another point. Now, similarly, for the second curve, put x is equal to 0, 5y is equal to 24, y is equal to 24 by 8. So, this is nothing but 4.8. 4.8. Similarly, put y is equal to 0, 2x is equal to 24, x is equal to 24 by 2 is 12. So, therefore, the points here, therefore, C is equal to when x is 0, y is 4.8. Here the point D, when x is 12, y is equal to 0. These are the points. Now, let us represent this in a graph. So, write on the graph. This is x-axis, y-axis. Take a suitable scale on x-axis and y-axis. 1 centimeter is equal to 1 unit. Let us take 1 unit. So then this is 0, 1, 2, 3, 4, 5. Maximum on the x-axis we have 12, 6, 9, 10, 11, 12, 13. Here on the y-axis, maximum we have 10, 1, 2, 3. Now, let us take the first point. What is the first point? A, 0, 10. When x is 0, y is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is A, 0, 10. So, first point is 0, 10. Second point is, so it is 5, 1, 2, 3, 4, 5. This is B, 5, 0. Draw a line which passes through these 2 points. A straight line. So this is. So what is this curve? The curve is 4x plus 2y less than or equal to 20. Since this is less than or equal to 20, the feasible region is towards the origin. Now another curve. What is another curve? C. Point C is 0, 4.8. 0, 4.8. Take C. 0, 4.8. This is 0, 1, 2, 3, 4, 4.8. Somewhere it is 0, 4.8. And D. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. D. 12, 0. Just draw a line which passes through these 2 points. Okay. Now this curve is, what is this? 2x plus 5y is less than or equal to 24. So again this is towards the downwards direction. This is the shaded region. This is the feasible region. So this is the feasible region. So these are the corner points. So what are the corner points? C, call it as E, and this B. So if you solve this, how much you will get? This E is equal to, so this is 3.3, 3.5. 3.3, 3.5. Okay. So therefore, the corner points are O 0, 0. This is one corner point, and C 0, 4.8, and then E 3.3, 3.5, and then B. What is B? Yes, B is 5, 0. These are the corner points. Okay. Now, so again further, what is to find is the, just substitute these corner points in the objective function. Just write on the objective function. What is the objective function? Maximum Z. Max Z is equal to 6x plus 8y. 6x plus 8y is the objective function. Now, what are the corner points? At corner points, so the corner points O 0, 0, then B 5, 0, then C. What is C? We have C is 0, 4.8, 0, 4.8, and E. What is E? 3.3, 3.5. 3.3, 3.5. So these are the corner points. Now let us substitute, just simplify this. What is that? 6x plus 8y. At 0, 0, this is equal to 0. At 5, 0, 6 into 5 plus 0, this is equal to 30. At 0, 4.8, this is 0 plus 8 into 4.8. This is equal to 38.4. And last, at 6 into 3.3 plus 8 into 3.5. What is this equal to? This is equal to 47.8. Now, what is the maximum value? 47.8 is the maximum value. So, therefore, this is the maximum value. This is maximum. So, the maximum is 47.8 at 3.3, 3.5. So, therefore, Z maximum is equal to 47.8 at 3.3, 3.5. This is the required solution for the given LPP problem. That's it. So, formation then solution by graphical method. So, if you solve this much, definitely you will get 5 marks. Okay. Now, let us move on to a similar type problem. A cooperative society of farmers presided by Lalit has presided by Lalit has 50 acres of land to grow 2 crops. So, 2 crops, that is X and Y. The profit per crop X and Y hectares are estimated to be rupees 10,500 and 9,000. So, the profit per hectare of X and Y is 10,500 and 9,000 respectively. To control weeds, a liquid to control weeds, a liquid herbicide has to be used for crop X and Y at the rate of 20 liters and 10 liters per hectare. So, the cost of the pesticides, that is the cost of herbicides, the cost of the herbicides. Next, further, not more than 800 liters of herbicide should be used in order to protect fish and wildlife using a pond which collects drainage from this land. How much land should be allocated to each crop so as to maximize the total profit of the society? Also find the maximum profit. So, this is also same as that of the previous problem. So, here there are 2 types of crops and the pesticides used, right. Now, let us assume that small x hectares of land is allocated for capital X and small y hectares of land is allocated for capital Y. Let X and Y be the land allocated for capital X and capital Y. Okay, right. Now, given what is so? Profit per hectare of X is, profit per hectare of X, capital X, is rupees 10,500. Similarly, for Y it is rupees 9,000, that is given. See here, the profit for X is 10,500, for Y it is 9,000, right, X and Y, right. So, therefore, the total profit is 10,500 X plus 9,000 Y. Since it is a maximization, therefore, the objective function is maximum Z. Max Z is equal to 10,500 X plus 9,000 Y. This is the maximization of the given objective function. Now, what are the constraints given? Subjected to the constraints. What are the constraints here? See, to control the weeds, a liquid herbicide has to be used for crop X and Y at the rate of 20 liters and 10 liters per hectare. Further, not more than 800 liters of hectare should be used in order to protect the fish and wildlife using a pond which collects drainage from the land. How much land should be allocated to each to maximize this? Okay, so the farmer, they use how many hectares of land? 50 acres. So, therefore, here the constraints are X plus Y is less than or equal to 50, right. X plus Y is less than or equal to 50, and whatever the given condition, 20 liters and 10 liters per hectare is used by, so 20x plus 10y is less than or equal to 800 liters. Okay, so if you divide by 10, you will get 2x plus y is less than or equal to 80, and the non-negative restrictions are x is greater than or equal to 0 and y is greater than or equal to 0. So, this is the required LPP model, right. So, what is the objective function? Maximum Z is equal to 10,500 x plus 9,000 y is 9,000 y, and subjected to the constraints x plus y is less than or equal to 50 and 2x plus y is less than or equal to 80, where x is greater than or equal to 0 and y is greater than or equal to 0. Okay. Now, solve this using graphical method, that is all. Now, let us solve this. So, max Z is equal to, maximum Z is equal to, let me write properly. Right here, maximum Z, max Z is equal to 10,500 x plus 9,000 y, and let us convert the given inequalities into equalities. x plus y is less than or equal to 50 becomes x plus y is equal to 50, and the second one 2x plus y is less than or equal to 80 can be written as 2x plus y is equal to 80. Now put x is equal to 0, you will get y is equal to 50. So therefore the first point a is equal to 0 comma 50. Again similarly put y is equal to 0, you will get x is equal to 50. So therefore the point b is equal to 50 comma 0. Similarly, if we put x is equal to 0, you will get y is equal to 80. The point c is equal to 0 comma 80, and put y is equal to 0, you will get 2x is equal to 80, x is equal to 40. The point d is equal to 40 comma 0. So let us represent this on a graph. Write on the graph. This is x-axis and y-axis. This is 0. Take a suitable scale. What is the scale? Let us write the scale on x and y axis. X and y axis. 1 centimeter is equal to, since we have maximum up to 80, 10 units is equal to 10 units. Now each is equal to 10. So this is 10, 30, 40, 50, 60, 70, 80, 90, 100. Okay. First point, what is A? A 0 comma 50, B 50 comma 0. A 0 comma 50, 0, 50, 10, 20, 30, 40, 50. A 0 comma 50, 10, 20, B 50 comma 0, 1, 10, 20, 30, 40, 50. Now just draw this. This is the straight line. Okay. What is this equation? So x plus y is less than or equal to 50. Since it is less than or equal to 50, the feasible region is towards the downwards direction. Now take another line. C, what is C? 0 comma 80. X is 0, y is 80. 50, 60, 70, 80. This is C. 0 comma 80. D 40 comma 0. 10, 20, 30, 40. D 40 comma 0. Draw this line. So the curve, what is this? 2x plus y is less than or equal to 80. Less than or equal to means again the feasible region is towards the origin. Okay. Now, so this is the shaded region. This is the feasible region. This is the feasible region. So therefore this is the feasible region. This is the feasible. Now what are the corner points? So these are the corner 0. This is A and call it as E. I'll write E and this point B. So what is E is equal to? So if we draw, this will cut here and here. So these are the values of E, that is 30 comma 20. X is 30, y is equal to 20. So therefore substitute here. Therefore the corner points, I'll solve one again. So now what is the objective function? Max z is equal to 10,500x plus 9,000 y. 9,000 y. Okay. Now at corner points, what are the corner points? O 0 comma 0, then A 0 comma 50, then E 30 comma 20, and then it is D. What is D? 40 comma 0. Okay. Now right at 0 comma 0 at corner points, Z, what is Z? Z is equal to 10,500x plus 9,000 y. Substitute here. Let me see. At A, 0 comma 50. When x is 0 plus 50 into 9,000, that's equal to 4,50,000. 4,5,000. 4,50,000. Next, at E. What is E? 30 comma 20. So this is 30 into 10,500 plus 20 into 9,000. What is this equal to? So this is 4,95,000. 4,95,000. Next, at D. What is D? 40 comma 0. So we have 10,500 into 40 is equal to plus 0. So 4,20,000. So these are the values. Now what is the maximum value here? So 4,50,000, 4,95,000, 4,20,000. So this is the maximum profit. So maximum. So therefore Z maximum is equal to 4,95,000 at 30 comma 20. That is 30 comma 20 means 30 acres of X and 20 acres of Y. That is X is equal to 30 hectares and Y is equal to 20 hectares. That's it. This is how we are going to solve this LPP. This is how we are going to form an LPP model and solution by graphical method. Hope you followed, right? So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.